In this video, we are going to review a force question. All right, this question says, a car stuck in the mud is being pulled out by two trucks. One truck applies a force of 1,700 pounds, and the other truck applies a force of 1,200 pounds. The angle between the forces applied by the two trucks is 72 degrees. The first thing they want us to do is they want us to find the magnitude of the resultant force to the nearest pound. All right, well, if this car is being pulled out by a 1,700-pound force and a 1,200-pound force, he's actually going to wind up going in this direction between the two forces, but a little bit closer to the 1,700-pound force since that one is applying more power. Now, if we want to find the exact spot where he's going to wind up, what we can do is we can create our diagram here into a parallelogram. It's not going to be perfect. And when you draw the diagonal from where he is to the opposite corner, that is going to be the resultant. That's where he's going to wind up. So when you look at the parallelogram, you really divided it into two congruent triangles, and we really just need to look at one of these triangles. So I'm going to take a look at this one right here on the bottom. Now we know that if this side of the parallelogram is 1,200, so is this side. And we know that if this side of the parallelogram is 1,700, not that we need it because we're not looking at this triangle, but so is this side of the parallelogram. And also, although they tell us that this angle in here is 72, it doesn't really help us find either one of these two angles because we can't just take the 72 and cut it in half and say this is 36 and this is 36. I mean, you could tell just by looking that this angle is smaller because it's across from a side of 1,200, whereas this angle is across from a side of 1,700. So the smaller angle is across from the smaller side, and the bigger angle is across from the bigger side when these two triangles are congruent. But what the 72 does help us with is this angle right here. We know that this angle and this angle adds up to 180. So if we do 180 minus 72, that leaves us with 108 degrees. So this angle in here is 108 degrees. Now what we're asked to find is the resultant, which is the diagonal. So I'm going to label that with, you can label it with an X, whatever you want. I'm going to label it with an A because in order to find that side, if we're working with three sides, so this, this, and one angle, we know we're going to need to use the law of cosines. So here's the formula for the law of cosines, and we're looking for A. So you can substitute in 1,700 for B and 1,200 for C, or vice versa. All right, so when we plug it in, we wind up with A squared equals 1,700 squared plus 1,200 squared minus 2 times 1,700 times 1,200 times cosine of the angle that is across from the side that we're looking at. All right, next, you can plug this entire right-hand side of the equation into your calculator. I wouldn't try to do it in parts. That's where people make errors when they try to do it in parts and add them together. So instead, just plug the entire thing in your calculator, and you're left with A squared equals 5,590,789.337. And then to get rid of the square, you take the square root. And if we go back to the question, it says that they want us to round it to the nearest pound, which means the nearest whole number. So we wind up getting the resultant to be 2,364 pounds. So I'm just going to put that over here. A equals 2,364 pounds. Okay, the next part of the question asks us to find the angle formed between the resultant and the larger force to the nearest tenth of a degree. So here's the resultant, and here's the larger force. All right, I'm actually going to change this A to a B for this part of the question, and this time we can use law of sines. If we're looking for an angle, we know the side across from it, and we know this angle and the side across from it, so we can use law of sines. We could say that A over sine of A equals B over sine of B. So for A, I'm going to use 1,200 over sine of A, this is the angle we're looking for, and for B, we can use 2,364 over sine of the angle across from it, which is 108. So when we plug it into our formula, this is what we get. So now we're going to cross multiply to solve. We can do 2,364 times sine of A equals 1,200 times sine of 108. Now to get sine of A by itself, we have to divide both sides by 2,364. And when we do, we're going to be left with sine of A equals, and you want to round this to at least 4 decimal places, so I made it 0.4828. And to finish solving for the actual angle, you would have to do the sine inverse of 0.4828. And when you do, you wind up, well, they want it to the nearest tenth of a degree, so you wind up with 29.8.